Well, folks, I'd like to welcome you all to the meeting tonight. And we always like to have God bless our meetings and our time together. And we have a special speaker tonight. We have Pastor Jeff Cahill, and he agreed to do the opening prayer. And so, Pastor Cahill, I will hand you the microphone. Thank you.
All right, thank you. Let's pray. Lord, we just pray a blessing over this meeting. Lord, we do everything here would be to honor you. Lord, we also ask you to draw our country back to you. And as we do that, Lord, that we would just see morality just come back to our nation. And we wouldn't hear of all the corruption. We would just hear of how their lives have been changed. Lord, I also pray for our men and women that are serving in our country, in our military, and in harm's way. And so, Lord, we pray that you would end this conflict quickly, and it would be permanent. And, Lord, you bring those men and women home safe. And, Lord, I ask all this in your Son's name. Amen.
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 Pastor Jeff, thank you very much. And can we just all stand and look to the flag, and we will pledge allegiance to
The flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Well, thank you very much. And going to be a way interesting meeting tonight. We're going to talk. You're going to leave here. You're going to know more about power transmission lines than maybe anybody in Montana when we're done tonight. But to get us started, I just have to go. We have a few things that we always do at a Patriot meeting, and I think one of the coolest and one of the most important things that we do is that we talk about our candidates. So if you're an elected official, or if you're a candidate, or if you're thinking about becoming a candidate, we'd like you to stand up and just briefly introduce yourself. And as the microphone goes around, you actually have to get this mic fairly close for it to work right. But I would just start it off because my name is Greg Kometz, and I am running for Senate District 18, very large district, runs basically from Miles City to the Billings city limits. And so that's who I am. And so we will just, yep.
Hey, Greg, we got one over here.
Okay.
My name is Ty Linger. I'm a Miles City native. So just within the last 24 hours, I have been asked to step forward and run for House District 36, the seat that Mr. Greg Kometz, the Honorable Representative, will be vacating to move over to the Senate. Now, a number of us were knowing that Senator King Bogner was going to be taking over that House District seat. It became apparent within the last 24 hours that that was not going to be feasible for him. And through numerous conversations between himself and myself, he has asked me to run in his stead. And so I will be officially filing paperwork tomorrow morning at 8:30 for that seat.
Awesome.
I'm a county commissioner from Richland County, Sydney. Dwayne Mitchell is the name.
I'm Randall Pinocci, your Public Service Commissioner, and my term is coming to an end, so I'm going to be running for Senate District 12 in the primary. I have a perfect A rating with the Christian Coalition and a perfect A rating with the National Rifle Association, Gun Owners of America, and the Second Amendment Foundation, and of course Montana Shooting Sports Association. I'm the Vice President. My opponent is F-rated on both, so it's really important you help get involved in this race. Thank you.
My name is Adam Porcelain, and I'm the Garfield County.
I'm Linda Harmon from Scobie, Montana, and I'm a Christian conservative and wanting to make a difference in our country and our state. Thank you. I'm running for House District 29.
Hello, my name is Mike Caldwell. I'm running for the Custer County term. Thank you.
Hello, I'm Jerry Schellinger from Circle. I currently represent House District 34, and I'm running for re-election to that. It will be my fourth term if I'm elected, and I serve on the Appropriations Committee there. And I don't think I have anything perfect, any ratings, but I got 7 perfect grandkids. So
Hello, my name is Gary Perry. I was the chair of the Energy and Technology Committee during last session. I'm running for my 3rd session, and I'm running in House District 35.
Hi, y'all. Kind of coming back home again. Jeff Pattison, I'm running for Randy Pinocchi's termed out Public Service Commission seat, District 1. So it's a big district, and I've been everywhere, man, across the country campaigning, man. So 15,000 miles already on it, man. So it's been a blessing and an honor getting to meet you guys and hear the needs and concerns that you have. Ag's always been my bag, so it's been always easy to talk about people about agriculture, because you eat in agriculture, and I kind of come to the conclusion that power's a little that way too. It's not a luxury; it's a necessity. So if you need to switch a switch and put some lights in there, we can talk. So anyhow, appreciate your support. Your prayers are more important. But Jerry, the thing that I have is got you a little beat on is I've got 11 grandkids that are perfect, and one on the way that's really going to be perfect. So, thank you all.
We got any more?
Mary, can you hand the microphone to Paul Green? I served with Paul in the 23 session. He drove down from Hardin, and I'd like him to say hello to us.
Hi, I'm Paul Green, served with Gary and served with Greg, several others here, Jerry, a lot of them up. It's Reinbaugh, absolutely. Really was a pleasure. Moved on, went back to the ranch, and just kind of want to keep helping the state. I was a part of one of the grant programs that worked with Grid United when I was the director for the Department of Commerce. Just want to see if there's anything that my network can still help with. So.
I'm Steve Heimbaugh, and I'm for freedom. That's what we all should be for.
Woohoo!
Birthday tomorrow?
Yeah, his birthday is tomorrow, so. Happy birthday to you. Happy birthday, Uncle Steve.
Happy birthday to you.
Thank you.
Woo!
Dennis Heskey, you going to say hello to the microphone?
Hi. I'm Dennis Pesky, County Commissioner from Prairie County, next one over. Like I said last time, I'm not running from anything or for anything, and I'm not running from anything. And on this grandchildren business, I got 10 grandchildren, but I got 6 great grandchildren.
Oh my God. That's because you're old.
And I have 18.
Losing this one fast.
All right, did we miss anybody? Okay, we'll keep going with the program then. But we always like to remind everybody about the little book on the front so that you can sign up, because we do try and contact you and remind you about these meetings, and we don't sell a mailing list, by the way. A quick reminder of the donation basket on the entry table. We do need a little money to make this thing go, and we're still looking for a couple people to make a $50 a month, 6-month commitment to the Patriot Roundtable. But we do thank you for the support that we have been receiving. Next monthly meeting is a little different because Easter Sunday, it's not going to work. It's not going to work. So next month, the Patriot meeting is going to be on April 12th. And you know, there's a lot of things that have happened in eastern Montana. You know, we now have big wind. We know that. And big solar is coming. And data centers are talking and making a lot of noise. So next month, we're going to talk about data centers. And we've got some great speakers coming. And it'll be an open forum. so you will hear the pluses and the minuses. And just like tonight, you will be able to ask questions. But on that note, I think I'm going to introduce our moderator. I have asked Randy Pinocci to be our moderator tonight simply because he is our PSC representative, and this is kind of his deal. He is basically in charge of electrical transmission in eastern Montana and several other things that he is going to tell you about. So I would like to just, if I could, introduce Randy, and I've got him a little introduction here, kind of figured out, and then I will hand him the microphone. Commissioner Randy Pinocci represents District 1 on the Montana Public Service Commission, a role he's held since first being elected in 2018. He was re-elected in 2022. His district covers a vast area, by far the largest geographically on the commission, including much of north central and eastern Montana. A lifelong Montanan, Randy resides in Sun River with his wife and 3 children. Before joining the PSC, he built a career as a small business owner in the printing industry, specializing in political direct mail for over 32 years. He served our state as a member of the State House of Representatives in 2015, worked as a statewide director for former U.S. Senator Conrad Burns, chaired the Second Amendment Committee for the Montana Republican Party. Additionally, he was a longtime board member of the Montana Shooting Sports Association. And folks, it kind of goes on, but I think I am just going to have Randy Pinocci come up here, and I'm going to hand him the microphone. You're all good, Randy. All right, fellas, thank you for coming, and we'll visit later.
Well, thank you for everyone having me here today. So we're going to do a little background on why this is so important. I sit on the National Board of Energy. A lot of people don't know that, and I work on the Western energy issues in the western part of the United States. The bottom line is we really don't have enough power in the western United States. If you were to draw a line from, say, North Dakota down to Texas and go over to California, we're not long on energy. One of the reasons this is because we wanted to shut down some coal plants, and when we did that, we really didn't have the power to replace it. Now, when we had all the coal plants, we were long on power, which means these coal plants weren't working at 100%. Some of them were, backed off a little bit on the throttle. But as they closed down, we had to make up for that energy, and then we became short. How we knew that is some days we go to plant our electricity needs, and they don't have enough, and they have to have a brownout, which means they have to shut the grid down, and people just don't have power at all. This happened in California a few times. The other thing that happened is your price of electricity increased. And the mistake was we shouldn't have shut down those plants if we didn't have the power to replace it. Okay? Well, one of the answers, they said, is we need to bring power from the eastern United States to the western United States. And we're not very good at that. So they're going to make a connection between North Dakota and Colstrip. And this interconnection puts this particular county and this district really in the spotlight. This is going to be one of the most powerful, expensive transmission lines in the history of Montana. It's going through your backyard. And a lot of you aren't aware of this. And so that's one of the reasons this meeting is happening here today. Okay? Now I want to thank these gentlemen who've all traveled from out of state to be here. That's a tall order to come all the way out here. But again, this is a very important interconnection and really is on the spotlight for the whole country to look at that's interested in transmission. Okay? Now, one of the things that I started about 6 years ago was I talked a little bit about improving energy efficiency to save you money. All right? So we opened an energy efficiency docket, and CTC Global, who's here with us tonight, helped assist with that. Your typical power line has a steel core in the center of it to give it strength. Now, steel has a couple of problems. It stretches and sags, okay? And then when we have sag, this usually causes the lines to touch in the wind, or it can actually break if the ice load is enough, And we have lots of problems with that. CTC Global designed a new line that has carbon fiber inside of it, which is twice the strength of steel and does not stretch and sag. And electricity leaks out of a power line like a garden hose with holes in it. We call that line loss. So when you pay your electric bill every month, some of that electricity you pay for just evaporates into the air. This new design line can cut line loss up to 40%. The other problem that I've been faced with sitting on the National Board of Electricity is fires have caused tremendous problems started by power lines. In California, the fires cost $1 billion started by utilities. So they ask for a show of hands of volunteers that want to battle this problem, and I'm like, sure, I'd like to get involved with that. And well, one of my ideas is we've got to start using this carbon fiber line that is twice the strength of steel and won't stretch and sag. And you might recall that Boeing is making their aircraft more and more out of carbon fiber. It's much stronger, the plane lasts longer. Boeing just broke the record, the 777, to carry the most weight on the least amount of fuel, and carbon fiber helped make that happen. So the entire industry in aircraft, aerospace, and conductors and power lines could turn to carbon fiber to learn something. The other benefits are they're putting fiber optics inside the line where they can measure the temperature of the line, the condition of the line. That's really important because if we know the temperature and we need a little bit more capacity, we could dial up the juice and know where that temperature is, because if you go too far, the line would melt and break. We also can tell where a bird is building the nest, where there's a short in the line, and if we can identify that problem before the line hits the ground and starts the fire, we could send a repair truck out. AI technology might be able to hook to this to monitor our lines in a way we don't even understand yet. The old steel core conductor is not going to be able to monitor the line like that. So it's kind of like this. This line technology came out in 1907. If you were to drive a car from 1907, you're not going to have anti-lock brakes, you're not going to have airbags, you're not even going to have blinkers, right? So I'm encouraging you to try to encourage the use of the safer line that'll cut line loss that we're able to monitor, okay? So we opened this energy efficiency docket, CTC Global and I did a few years ago, and brought it to the legislature, and I said, I think we could save you millions of dollars in preventing the fire, in paying for electricity that just evaporates in the air, and also we would reduce sag, and there's something else. The line can stretch farther, so when you're putting in a new transmission system, you don't have to put in as many structures or power poles because we can stretch the line. This saves you, in this case, these structures, and you'll ask Grid United, could cost over $1 million. So if I could do 20 or 30 less structures, it's going to save you a lot of money, okay? So these are things that I wanted you to understand that we started. So then the fires became worse in California. So these two gentlemen here, we've got Joseph Sylvia with Epsilon, and we got Peter with CTC Global, attended a meeting in San Francisco. And I can't make this up, when I was taking the stage, an earthquake hit. So I think God really wanted everybody to listen. Anyway, I explained how we could reduce the fire risk in California. No fire has ever started with a carbon fiber line that's been properly installed anywhere in the world. Not one. I was trying to explain this, and we really have to focus on using this new technology to reduce the fires. And that was what, guys? 3 weeks before the fires hit, it cost over $1 billion. That was the timing of that. So we wound up in a couple of national magazines, and I think we were in a French newspaper and in the London Times, that I was trying to explain all this just before those fires hit, okay? So my job as a public service commissioner is three things: safe, reliable, and affordable. And I think this technology fits all three. It's safer because it's twice the strength, right? It's affordable because we can put in less structures and I cut the line loss down, right? And the reliability's there because I'm not going to have the lines breaking and starting these fires. So when a fire starts, the utility pays for it, but sometimes they raise your rates to cover it. In the last session, they had a bill where the utility kind of got out of the liability situation. Well, then I think we need to look at having a car with airbags, a car with anti-lock brakes, and I think this new technology is that. So first I'd like to introduce CTC Global, Peter. And Peter, I'd like you to introduce yourself and tell us a little bit about your new technology that's leading the whole country on being able to monitor the line.
Thank you, Commissioner. Very happy to be here, very honored to be here. Flew in from Reno, I guess, last night, actually from a wildfire conference that we were at. CTC is the original developer of the carbon fiber gas conductor. And as Commissioner Pinocchio said, this is your 1907 technology. It took off actually prior to that, early 1900s, most power lines were still copper. Okay, sorry. Prior to 1907, most power lines were still copper. They started to develop the concept of the ACS. ACS stands for aluminum conductor, because the aluminum is the conductor around the outer edge, and aluminum conductor, steel reinforced. Because the steel carries most of the strength, the aluminum still carries part of it. It didn't really take off until the First World War, and you might guess why it didn't take off in the First World War, where there was a huge copper shortage because of all the copper needed for the bronze, for the shell casings and things. So once it took over, it's been a dominant conductor ever since then, and I'm guessing 95% of all the conductor plus in the United States is still this. We developed, the story is, I wasn't with the company at the time, but several of the engineers were working in the aerospace industry. As Commissioner Pinocchio mentioned, as you know, a lot of the modern airplanes are built with carbon fiber, and they had to be taking lunch under a power line on a hot day in the summer in Southern California and realized how much it was sagging, and they were thinking, well, carbon fiber would do a much better job because carbon fiber doesn't sag when it gets hot, or doesn't sag nearly as much. So they developed it. We have about 125,000 miles of this around the world. We dominate the markets around the world where you have rapidly growing transmission markets, which has not been the case in the United States. The United States has not had rapidly growing transmission markets probably for 50 years or so now, but that's changing, and I think we'll hear more about that today. So this, we're here and we work with Grid United. We're actually have some organizations with them. We're hoping to encourage them to look at this technology for this really transformational project that they're doing. This is in some respect, eastern Montana and part of North Dakota, you're going to set a new standard in the United States for transmission with this Northwest Connector, I guess is the name of the project. And I can talk more about this later, and happy to talk, but I want to make sure everybody gets a chance here.
And I apologize, I really should have had Grid United give a presentation first to explain the project, so Brent, I'd like you to do that. And I'd sure like you to explain how this came about, and maybe you could show us a map of how the route's going to happen and how soon this project's going to take place. So, sir, I want to turn it over to you.
Let me plug in my computer. Okay, so happy to be here tonight. This is called the North Plains Connector. My name is Brent Johnson. I'm the Senior Vice President of Development at Grid United. Thinking about it. Okay. Commissioner Pinocchio said we all came from out of state. I didn't. I actually drove over from Bozeman. I live in Bozeman now. I've been in Houston for 25 years. I grew up in Great Falls myself and spent all my growing up years in Montana with a short beginning in North Dakota. So this project that connects Montana and North Dakota has been fantastic for me to be able to come back home, which I've been trying to do for 25 years. And living in Houston was, I wondered for 25 years what I was going to do every Saturday. I never did figure it out. Now I've got that figured out, and I've done a lot of fishing and skiing and hiking. So happy to be back and happy to be here. So the North Plains Connector has been under development for about 5 years. So we started, I think that the first concept was in September of 2021. That might seem like a long time, but in the United States, most of these large-scale transmission projects have taken decades to build, and we are 4 years in. Grid United started with with a mission to connect key areas of the grid in the United States to create a more efficient and reliable system, taking advantage of all the nation's resources for the benefit of all consumers, and really along that theme that Commissioner Pinochi talked about, from North Dakota down to Texas, there really isn't a lot of transfer capacity back and forth across the eastern and western grids in the United States. So this project is the first one out of the gates. When they gave this to me, it was, hey, here's 2 points on the map. You can connect these 2 dots. That would be great. You can have pretty much flexibility however you want to do it. For me, that was crazy. I've been doing linear infrastructure for most of my career, largely as an attorney, supporting land and environment and regulatory issues. Then I moved over and ran land and environment for a while for a small company called TransCanada. I'm sure you've never heard of the Keystone XL project. I worked on that off and on for 3 different administrations. And they came over here after the last time Keystone was killed. So having worked in linear infrastructure, knowing that connecting 2 dots with all of the land and community in between is really hard to do. It is a challenge, and it was an opportunity to start and do it right from the beginning, to make that top project, connecting Montana to North Dakota, a reality. This is the route that we ended up with. I know it's probably small from back there. Hopefully you can kind of see what we're doing. We're kind of going from Colstrip over to just southwest of Bismarck. That blue line is going to be a high voltage DC current line. An HVDC, the benefits of that is it'll be bidirectional, can go back and forth. And on either end of the blue line, there will be a converter station that will connect AC lines from both sides of the grid that are asynchronous and convert that to DC. You can travel a large span in the middle without much line loss. And it's bidirectional. You tell which way it's going to go, and within minutes of change, you can just switch that back and forth to respond to the market as needed. Kind of like a big breaker. It's an intertie between 2 grids. We're not affiliated with any particular type of generation. We don't own any generation. We're just building transmission line. Those 2 yellow lines are both AC lines that connect to the North Dakota grid. One goes to SPP and one goes to MISO. Those are the large grid infrastructure organizations that are in the Eastern Interconnect. One of them kind of connects to the Great Lakes area, and the other one kind of goes south of there. Big organizations that have all combined and pooled assets with big integrated markets. So this project allows the Western market and the Eastern market to connect to one another for the benefit of whoever needs the energy at the time. Just for perspective, this is kind of a map showing what we're doing, just connecting the grids. This on the left, it kind of shows the transfer capacity across the grid now, mostly 200 megawatt, small capacity back and forth to just serve local interconnections. This project will more than double the transfer capacity between the eastern and western grids with one project. Okay, this is just showing a brief timeline. We started right-of-way acquisition and talking with stakeholders in 2022. We've studied the line. We're doing this a little bit differently than most projects. We've studied the line in detail, did all of the environmental surveys and the tribal surveys and the archaeological work, all before we filed with the federal government. They were kind of synced up with Montana and the federal government, so those timelines overlap. But we started permitting at the end of 24, and we think we're on target to be done with all of our permits by 2026. So when you think about that from concept to a full EIS and federal studies in 5 years, that is going to be that'll be record time for a large project like this if it's able to stay on track and it all looks good so far. We're currently through the draft EIS. I know I've spoken with some of you in the recent public meeting here in Miles City. I know we've got some landowners in the room as well. We appreciate the support. This project is in the draft EIS phase. That means about 6 months, 8 months from now, we should have a final EIS. And they were really close to being finished up with our permits. So No real opposition to date. We've got a few comments came in from the last round, just encouraging us to take a closer look at certain things, which we appreciate and we'll keep doing. But we're on a good track to get our permits. When we get our permits, it will take about a year to get ready. We've got those converter stations on either end of that blue line that you remember. Those take a long time to build and design. So we've already started the front end engineering on those. We'll have to finish that up through 2027, and we'll really get started with construction in 2028. It'll take about 3 or 4 years to build this project. Not so much the transmission line, but those 2 converter stations on either end are very large projects, and they'll take some time to build. We won't go into much detail here. I know you can't read it from back there. The point of this slide was what we've already talked about. The permitting on this project is all synced up with the feds and Montana DEQ, who's doing a great job. Synced up together so we can efficiently have everything looked at. North Dakota permitting is now underway. We've got 6 of the county permits, or 5 in hand, and 1 will probably come in about a month and a half. And we're with the PSC in North Dakota. That's kind of the process there. Counties first, and the state permit, and that should be all done by the end of the year as well. A lot of talk about permitting reform over the last several years. Started with the Trump administration last time, and then everybody swapped hats but had the same ideas during the last administration, and people are still talking about it. I would just say on this project, this site tap program, we're kind of the front runner for that, and this program kind of ignores the necessity for permitting reform legislation. We just got a bunch of old people who've been around doing transmission for a long time or pipelines for a long time said, what would it look like if we just had the Department of Energy coordinate everything with us and have some staffers and get this done in 2 years. It's so far it's working. So, if you ever hear about a big project that needs a shorter timeline, there's ways to do this. And it's really based on doing your stakeholder work up front, your landowner work up front, and then spending a little bit of dollars to make sure you hand the government a project that's largely been studied already, and you don't have to, propose things and then everybody argue about it for 2 decades. So that's been the idea from the beginning, and with that, I'm happy to take some questions about the project.
In you. Before I turn it over to Joseph, I want all of you to be thinking about some questions you'd like to be asking. This is a once-in-a-lifetime project. This happens like every 60 to 100 years. That's been our track record for something like this to happen. And it's going through your backyard. I want you to keep something else in mind. Great, serves on energy, and if I'm able to win this race, I want to serve on energy. And I used to serve on energy when I was in the legislation. So I think that's kind of important because this project's going through here. I invited Daniel Zolnikoff and his wife, who one sits on energy in the House while the other sits on energy in the Senate. No, you're shaking your head. I thought they both serve on energy.
Amy can't. She was the representative.
But she did last session. That's what I meant. So I invited them, but she's about ready to have a baby. Like tomorrow or something, so they couldn't come. But they did both serve on energy, one in the House, one in the Senate. So I want you to know I invited them. And so be thinking about some questions. I want you guys to interact with this. Joseph, go ahead, sir. Thank you.
Thank you very much. And thank you, everyone, for having me. I'm Joseph Sylvia. I'm Director of Business Development for Epsilon Composite. So Epsilon Composite's been carbon fiber protrusion for 39 years. We make multiple components in critical infrastructure and other things. We're a Tier 1 supplier to Airbus, so we make structural components for the A350 and the A380, and we're really excited to be here in Montana. I thought that this was an interesting graphic. So this we've talked about the evolution of overhead conductor, and this kind of visually walks you through what's happened over the years in terms of overhead conductor. So 1880s, you've got full copper conductor, and then as mentioned, in the early 1990s, 1907, you have steel-supported ACSR conductor, and that's mostly what's being installed today. Then in the 1970s, there was ACSS, so a stronger high-temperature steel in the middle. It allowed for more ampacity, but it's still steel. And then in the 80s, in the 90s, and the 2000s, we've slowly kind of come up with new fiber architecture, different types of composites for this application. But again, when we look at a big connector like this and all the money going into circle 1907 when there's all these other possibilities, there's other tools in the toolbox that we should be considering. And that's really, I think, CTC and Epsilon are both aligned in that, to work with the engineers and implement a better solution from a material science perspective. So looking at these cores really quickly, we hear composite. Here's basically what they're made out of. So carbon fiber on the inside, glass fiber on the outside, and then the resin. The resin is the glue that holds it all together. It's what gives the product its thermal rating, and it's actually the most cost-driven aspect of these composite cores. So if we think about that, and we think about the flexibility we have in composite manufacturing, we can make a whole array of strength members at different costs and different performances. And that's really our point to Grid United and anyone else willing to listen, is that instead of going with the kind of out-of-the-box commodity 1907 product, we have the ability to look at your thermal ratings, look at your costs, look at what your needs within the existing corridor, and manufacture a composite that meets the price point. If you look at, in this line in particular, you wouldn't necessarily need to run it at the full 200 degrees Celsius that a standard composite core or an expensive composite core. So we have a composite option. You'll notice down here, it's only 1.5 times the cost of ACSR. So it's not the high temperature 2.5 times or 3 times per foot. It's only 1.5. So if your ACSR is $3 a foot, this would only be $4.50 a foot. And that's very considerable when you start looking at the structural savings, as mentioned before, that you get when you're implementing a carbon fiber composite. In addition to the core, we also can work with the stranding. This is just simple hard-drawn aluminum that's on the outside of this. We can make fully annealed trapezoidal aluminum. We can do round wire fully annealed aluminum. We can also put coatings. There's a few hollow strands that you can use for corona mitigation. So all of this is to say, rather than get into the weeds here, as we look at this ACSR conductor from 1907 and we look at new line construction, we should really be engaging on an engineering level about what's possible from this wire. What can we spend? What kind of performances can we get? And it's a science. And we're happy to work together. We're here to talk to anyone ready to listen. And we believe that substantial savings could be realized on this both initially and before.
Did you put some information on the tables?
I did, yeah. So I just left some very high-level brochures, and I also left a carbon fiber composite ruler. So feel free to use that if you measure something. It won't expand, so you'll get the same measurement every time. Sorry, I didn't bring more, but that thermal expansion is a consideration when we're talking about transmission, so it all plays a role. And again, thanks everyone for having me. Excited to talk about better water.
Okay, so I'm pretty excited about this. I'm going to get down here with the group. I want to pass these samples around so you guys can take it from table to table. So this is the steel core and carbon fiber. I'd like you to pass that around. I'm going to start with a question. So a lot of you helped me get elected, and I promised you that I would stay engaged with this district, and if I could save millions of dollars, I would. Now, in Seattle, Washington, I had a meeting with Grid United. We actually had dinner together. I think it was Michael Scully. And where's he from, sir?
He's confused.
Okay, so I asked him to come here. So I assumed when somebody did, it would be from out of state. It's exciting to see you from Bozeman. So Michael Scully is like the president or the CEO of Grid United. And I said, sir, I think I can save millions of dollars, and my district expects me to do that. Now, here's my idea and my first question. We look at this map. Could you bring the map back up, sir? And could you tell us how many structures are going to be built in the permitting process? So every structure is this big steel tower. They've got to get a permit to put it in. How many steel structures do we have on this span? Okay, now here's why, while he's looking up that answer. I was telling Mr. Scully, the CEO, if we use carbon fiber, we can stretch it farther and put in less structures. Sir, is a structure over $1 million each with the permitting?
So here's the problem. I'm a lawyer.
Okay.
So I'm not going to have all of those type of details with me tonight. I didn't know you wanted that, but
Sure.
yeah, they'll be very expensive structures.
You bet.
They could be
Okay.
$1 million.
So I was telling Mr. Scully, now look, if we use carbon fiber, we'll put in less structures. Now, the line may cost more, the carbon fiber may be more expensive, but if I can save $1 million on a structure, I can buy a lot of line. Okay, well, if your commissioner has an idea to save millions of dollars, do you want me to tell him? Of course you do. And that's what I did. So I said, we need to have this meeting, and I really appreciate you being here so we can discuss this. All right, there's another savings. If we can stretch the line farther and we have less structures, if I have less line loss, that means you're not paying for electricity that just evaporates in the air. Now this gets a little confusing. This is a large line that's like 500 kV. When you're using DC, it's pretty darn efficient. You don't have that much line loss. Line loss is really bad with the lines you have right outside this building. 345 kV and down. When we get to the bigger lines, our line loss isn't as bad, but still, we will have a benefit cutting line loss, and I want you to ask Peter and Joseph that, but maybe 2%. But that can be $1 million a year that you're not paying for nothing, right? So I was telling Grid United that if we can save millions on the tower and we save millions on line loss, we have to have this meeting. And I think a good place to have it is where the line is going to cross your backyard, Mr. Kometz's district and my district. So we want to do a good job for you, and that's why we're having this meeting. And I want you to be involved with that. But there's other things. The carbon fiber has the ability to monitor the line, what the temperature is, where a short might be happening before the line breaks. It might be able to monitor other things where AI technology hasn't really come out with an idea. But if we use the old steel core conductor, we're not going to be able to monitor anything, right? Now, let's talk about some monitoring. Let's say we have a power line go down, and we got to route power the back door to the town because there's an outage. I can have a monitoring system on a computer, maybe use an AI, and we can reroute that power maybe an hour sooner. Okay? Much quicker. This type of monitoring is important. And remember, I've been challenged because I volunteered to lower fire risk. If the core is twice the strength or much stronger than steel, I reduce fire risk, and when a fire happens, you usually wind up paying the bill. If I can save millions of dollars in one state reducing fire risk, I'm saving the fire department from fighting the fire. I'm saving you money, safe, reliable, and affordable. So I think these things are worth talking about. So my question to you is this. If the permitting's already done, maybe it's too late to remove these towers, or could we redraw the map with less towers if you consider using this technology? Do you have an answer for that?
Yeah, I think that, so permitting is going to be done, but it's, when you look at the permitting that we're doing, you're permitting a corridor, and so we do have towers placed, and we do have geotech that's being done this year to try and figure out everything that has to go into the engineering. But we're sitting at 60% design right now, so we'll have to take that up to 90% and then eventually issue for construction. So we haven't done all the detailed engineering just yet. So when I did talk to our engineer, I knew that you guys were coming. She said they are speccing out advanced conductor with the carbon core. Whether it's these particular conductors, I don't know. But I'm happy to connect you guys with our engineers while they're going through that 60 to 90% design. So yeah, if there's opportunities to diminish the number of towers as they fine tune that design, it would all stay within the existing corridor that we've studied. So it's possible to do all of that advanced engineering as we get from 60 to 90 and still stay within our permit corridor.
Okay, here's another question. If we're able to use carbon fiber and we can stretch it farther, Joseph, it's true that the tower won't have to be as high, and we can reduce the height of the structure, which could save millions of dollars of steel across the entire route. Is that correct, sir? So on a new line, Mike, please, and talk loudly in the mic so we can hear you online.
Will do. Thank you. So on new line construction, you have two options in terms of structure mitigation. You can either space the towers further apart and have big honking towers still, or if your towers are already set and the locations are fine, we can just lop 10 to 15 feet off the top of all those structures, save all that taxed steel, and put in the new carbon fiber that's lighter and doesn't sag as much, and you maintain your sag clearance violation with shorter structures and even smaller foundations as possible. So lots of dials to turn and knobs to tweak, and we got to work together with engineering to say, this is what the composite can offer, here's how it's implemented properly, and here's how you gain 100 years of safe, reliable, and affordable.
Okay, Peter, you want to tackle that? CTC Global.
Completely agree. You actually can do a combination. You can have fewer tires and shorter. It doesn't really make sense to do that. You're going to save the most money by far by reducing the number of towers. And part of it is frankly what's happened the last 2 or 3 years with the tariffs. So steel costs have gone up. We've talked to some, in fact, there's one state in the country that actually owns a lot of transmission, and they were working on a second phase of a transmission upgrade project we're doing, and realized that their towers have gone up, their costs have gone up by 60%, almost entirely from steel. I'm sure you've seen that in probably cost of your system. The other part is you save on the steel, but the second biggest cost is the foundation. The foundation is primarily labor, and as many of you probably know, labor costs have gone up dramatically in the last couple of years ago. So yes, you can shorten it, but you're really going to save money. You're really going to save money by reducing the number of towers
And foundation. See the benefit of having 2 separate companies here? I've got Epsilon and CTC Global. Now let me tell you what's really frustrating, folks. I'm traveling the country, and I can't tell you how many transmission projects are going up in this country right now that are using steel core conductor, and they're putting in a lot of towers, costing you billions of dollars of spending. What we're doing here, having this meeting, can save you and this company millions by having this meeting. Right now, transmission's going up all over the country, and they're not having this meeting. They're using steel core and more towers. And I'm desperately trying to get around the country as a volunteer. I don't get paid to do this. And something else, I don't regulate this. I can't make these guys do it this way. I'm here as a volunteer to show you that if you're going to be an elected official and you put a little effort in it, I can save millions. Billions. If we can save $1 million a year in line loss, and this lines up for 100 years, that's $100 million in savings. Let me ask Joseph and Peter, how long will steel core compare to carbon core? I know that carbon core can stay up longer, more years. Joseph, why don't you take a shot at that, and then I want to CTC Global to chime in.
Sorry, go ahead and repeat the question.
Okay, steel core, let's say the lifespan is like 50 years. And some of that depends on weather, but carbon fiber is going to last longer.
Right.
What do you think this line can last if we install carbon fiber?
So testing suggests that these steel core conductors last around 4 years. And the composite, because it's non-corrosive, it's got an epoxy resin matrix that's been designed for this application. Test reports suggest that these composite cores last upward of 120 years. So when you're talking about longevity and line loss reduction over a certain period of an asset life, it's substantially considerable. I don't know if CTC has something to add.
Let's see this for you. So this one for you as well. Yeah, basically what we tell our customers is basically it'll last every bit as long as a steel core conductor, if not longer, except in corrosive environments. And in corrosive environments, it'll last a lot longer. Basically, Brandy passed around my sample there, but the steel core next to the aluminum. Any of you boaters? Any of y'all boaters here? Boats? Well, are you familiar with sacrificial anodes on your engine? So basically, anytime you have 2 dissimilar metals close to each other, you get a natural galvanic effect, which basically corrodes over time. With the carbon fiber, we have, as Joseph pointed out, you have the carbon at the center. That's the black that you see. The gold you see around it is actually high-tech fiberglass, which is a great thermal insulator and a great electrical insulator. So basically, there's no metals, there's no corrosive effect between metals that you have with the traditional steel conductors. So basically, particularly along seashores, seacoasts, the traditional conductors don't last as long. The industrial area where you may have solvents or stuff in the air doesn't last as long.
Another quick point, good point on that. The composite is non-magnetic, so there's no magnetic considerations when you look at voltage drop or voltage over long corridors. It's an engineered wire, looking at all the variables, past the year 1907. So it's a better solution for sure.
So I had this question. My district's a little unique because I have Mountster Air Force Base in it. Any of you realize that if Montana pulled away from the rest of the United States, we'd be a third nuclear power? Anyone? That's how many nuclear weapons we have here. So let me ask you this. If China or Russia wanted to do a preemptive strike, they'd probably use an EMP to knock down our system before they did an attack. Here's a question for you, which I don't have a good answer from anyone. If we're going to have an event, an EMP event from the sun or a weapon, is steel going to react more violently or carbon fiber? So I went to a company who kind of grades power lines, their strengths and weaknesses, and I asked them that question, and they said they don't have an answer for that. And I said, well, I think we should start testing for that, because my district might want to have something that puts up with an EMP event. And let me ask you guys, there is no testing on that, but would you guys think that carbon fiber would withstand an EMP event from the sun, which EMP events from the sun cost our grid across this country millions of dollars in damage every year? Anyone heard of the Carrington event, 1859? Solar flare from the sun that was so violent that daytime it happened during the night. People got up thinking the sun was up, and it was an EMP event. We have a telegraph between, railroad station to railroad station. The line got so hot, it turned red hot, and it caused trees to burst into flames. If we have that event again, and it's not a matter of if, it's a matter of when, our entire grid is going to be in real trouble, okay? So I've been trying to say, when we're going to install new systems and transformers, that we should be thinking about making them EMP resistant or EMP proof, right? And Germany's doing this. Do you guys have any input? Do you feel carbon fiber would put up with an EMP event better than steel?
I would think so. I would want to see the testing before I take the stand and say it would absolutely. But again, it's stronger, lighter, more thermally capable. It's non-corrosive and non-magnetic. So I gotta believe yes, but again, I would want to see the testing done, and I think we should do the testing. It's something we could probably team up with CTC and join the testing and say, hey, carbon fiber's better for this situation.
Peter, what do you think?
I think those will. Joseph, you'll hold up your samples. Someone have mine. You're on the ACSR one first.
Okay.
So again, you have dissimilar metals. So the steel core at the center has a different resistance than aluminum. That's actually interesting in a number of cases because it potentially increases the wildfire risk as well. So the fact that you have two dissimilar metals next to each other, I assume Epsilon's probably very similar to ours. Again, with the gold around the outer edge, there is fiberglass that's insulated. So you have an insulated core that wouldn't transmit any electricity. So in theory, yes.
And sir, we'll get to you in a minute. So my goal, safe, reliable, and affordable, and I happen to have one of the largest nuclear facilities of weapons in the United States. So if I'm going to look out for my district, and keep in mind, I'm the only public service commissioner that has nuclear weapons in the district, then Jeff, that'll be your responsibility if you win this race. By the way, I'm endorsing Jeff because he's listening, he's working with me, and he has for a long time. Safe, reliable, and affordable. I got to be thinking about this. And here's what's outrageous. We don't test on what line puts up with an EMP. I kind of think we should be on the ball with that. So I'm encouraging the people that test these lines to start throwing that into the mix, all right? Because an EMP event from the sun is kind of important. And remember, I'm looking out for 120 years out. And is it safe to say we can cut $1 million a year in line loss by moving to this product?
Yes. It's safe to say that. Those are conservative assumptions. For the same overall diameter and weight, if you add 28% or more aluminum content, and you look at this DC application and the amount of losses associated with the line, roughly $1 million a year is a conservative number looking at the project. Yes.
Peter, what's your thoughts?
Yeah, I would think one of the advantages here is, as I mentioned earlier, this is a transformational project. Already, it's going to be twice as efficient as traditional conductors would be. You could still cut that efficiency by 30%. So yeah, I would say
I mean, this is a big line. I mean, they could have a lot of power, so $1 million a year might be at the low end.
So let's say it's $2 million. 100 years, $200 million in savings. Do you guys think that's substantial? I'm supposed to be looking out for your future. How about your grandkids' future, right? So these are the type of questions I have. But now I want to go over to you guys to ask questions.
Okay, thank you for that.
They're talking to the mic.
My name is Butch Crutchfield. I'm a retired attorney and landowner in Custer County. So I have some observations, and this comes from not knowing all the details like you guys do as experts. But first, my observation is some of the people that raised grandchildren must have had the lights out in the bedroom. So having said that, I have a question for Joe and also for Brad and or anybody else wants to respond. It just seems to me that if you're worried about security from wind, from SAG, from solar flares, from the Chinese or from the Russians disrupting your system, I'm wondering about the feasibility and if it's possible to do 500 megawatts in a pipe that's underground. So I know that carbon fiber is being used underground with all kinds of applications and monitoring and everything else. So if you're underground, at least near cities or near your converting sites, it looks to me like you minimize and solve some of the security risks and also some of the safety risks from wind. So I don't think that we have fully recognized on some of our thinking, Brad and Joe, of what the impact of Mother Nature can be. And so when you have a system that's in the air, whether you have you don't need I'm for the project, don't get me wrong, and I'm also don't have to be sold on the ability of your new product. That's not the question that I'm talking about. I'm talking about, is there a better way, and what is the best way that we might do this? So to solve some of your SAG issues, it seems to me, if you got winds in excess of 100 miles an hour, eventually you're going to have a problem. I don't care what kind of line you got. So question, Joe, can you do 500 kV underground? That's the first part of it. And then the second question I have is just two. The second one is for Brad, for any of you, is what about the feasibility of using a route that uses an existing Western Area Power Administration corridor that's already there? It seems to me that line, and I've been told, is getting close to being replaced or needing replaced. So you know that's going to be something that's going to happen probably in the near future. You got 200 kVs going, and you need 400 or whatever you're designing for. It just seems to me that some thought, and I'm wondering if it's been considered properly, to use that corridor in a more efficient manner, because it's already there. You already got lines on it. If you can add to your existing towers that you have and strengthen them, I can see where you got a economical and efficient possibility on this thing. So I'm wondering why you go out with a whole new corridor when you have that sitting there. Now I understand that you're far along in your process and thinking, but if you were trying to solve SAG, security, safety, and cost, it seems to me there might be a better way to do it. So your response, please.
Yeah, thank you for the question. It's a good one. So typically when we look at overhead versus underground, underground is typically 10 times as expensive per mile. So what's the current budget on this year project? 6 billion times 10, that's a hefty price marker. Affordable, from a cost perspective, underground is not going to be the way to go. But these carbon fiber composite cores, when you talk about wind, blowout, all of the elements that is experienced by an overhead line being overhead, the carbon fiber composite is far more resilient and far more strength oriented and designed for these things that the wire is going to come into contact with. To Pinocchi's point, this is why more and more airplanes are being made out of carbon fiber composite. They resist cyclic load fatigue. They maintain thermal capability in very demanding conditions. So the cost, the hybrid solution is going to be an aerospace grade carbon fiber strength member overhead. So spend a little bit more on your wire maybe, but it's not going to be 10x, and you can realize benefits overhead as opposed to that 10x.
Where do you get the 10 times number? I mean, why are you saying 10 times?
That's the industry standard. It's a generally accepted industry rule. Every certain amount of feet, you have to put in an underground vault. Those are extremely expensive. Underground is extremely expensive for a number of reasons. And I don't work in the underground world. We sell all overhead because of this fact. And so I'm a little bit out of school, but I just know that when we talk about and we look at, if you want to do that, just bury it. The price tag associated is cost prohibitive.
And to that specifically, California's looking at it quite a bit right now because of the wildfires that they've had in recent years and all the damage. And they are doing some undergrounding. Most of the undergrounding they're doing is actually distribution lines, not transmission lines. I think all the undergrounding they're doing is distribution lines. If you really want to go underground, high voltage, long distance, you go with superconductors. Before I joined CTC, I was with American Superconductor. Great product, great ideas, but even then the cost gets dramatically higher. But here's a good question for you to follow up on the why you couldn't use existing lines and why you came up with this project. I have an idea what the answer is, but I think you know better than I do.
Yeah, which is, it was probably the first meeting we took. I had the same thought you did. I said, wait, what? I drive up and down this freeway, there's the WAPA line sitting right there. And we talked to WAPA, and they had zero interest in doing anything. It didn't match their mandate, is what they said, for the federal government. They were to serve local load, they were to manage the federal government's resources, they were not really supposed to be upgrading or doing anything like that. It made a ton of sense. So that is where we started, and it was a pretty quick answer, no.
So what you're saying is you had no federal interest at that point?
That's true.
So what about now?
I still think it's a long putt. To try and rebuild some of that stuff, I think it would be a great idea. I think besides just WAPA, I think a lot about BPA. I think there's opportunities that I would like to explore. We are trying to do some of that, but so far we've not had a lot of luck yet.
Thank you.
I want to take a shot at explaining this answer, and I'll get to you, Jeff. When you look at underground transmission, most of you think, well, the line between the power pole and my house is buried under the ground. It's no big deal. Transmission, high power transmission, is a little different. First off, they want to be in a tunnel. A tunnel about 8 feet wide, 8 feet high, and then they run the transmission lines along the wall. And Greg and I are in the tunnel, and I'm showing them the lines, and all of a sudden, the 5 o'clock hour is coming, and everybody's going home and turning the power on. The temperature on those lines is getting to 200 and some degrees, maybe even higher. That tunnel is going to cook Greg and I before we can get out of it. So they have to put air conditioning in that tunnel. And that's what happens in the big cities. So when you think that we can just do this underground, keep in mind we have to have a tunnel that's air conditioned. 10 times the cost. It's just not feasible. But we have to do it in some applications. Imagine if you and I were in the tunnel and I'm saying, well, we're 30 minutes from the manhole and we're not going to make it. And we're going to cook in here. That's pretty scary. But people don't think of underground transmission like that, do we? The difference between distribution and transmission is radically different. The ambient air cools that line. Something else I bring up in my meetings when I'm in Washington, D.C. I show a map of the United States and I say our transmission should run in the northern states, not the southern states. Why? Temperature, you bet. It's below zero, I can run more power. It's ridiculous for us to build transmission in the southern states. We should be running them in the northern states because I have the ambient air conditioning. See, that's the type of thinking that I want us to start looking at. Yes, sir.
Why do you say tunnel? I thought was pipe is a possibility. Is it?
We can take a look at some underground transmission that is in the tunnel. We have to be able to air condition that.
No, I'm talking about pipe. Your carbon fiber in a pipe.
Well, it's a temperature problem. Okay. The temperature of transmission, when it gets under heavy load, could maybe melt that pipe or cook the system. We gotta keep it cool.
The Earth is 56 degrees in the north.
Well, we can talk about that after the meeting, and I'll show you the diagram. Joseph is right. Transmission is 10 times more expensive underground.
It's 56 degrees.
In town.
Yeah, it's 56 degrees when you're not adding heat to it. So basically, unfortunately, ground is a very good insulator. So you can't, the heat can't be removed from the line.
I see.
Okay, I think Mr. Pattison was next, and then we'll get to you later.
Thank you, gentlemen. It's really been a good hearing, and I've really learned a lot more. I just came back from a conference down in Florida with data centers, AI, and Universal Service Fund. One of the things that they were talking down there with the app, and you guys mentioned it here, with the capacity possibly of fiber optic maybe going through there. Would that be an intrusion into, if it was a data center, to move information back and forth on Corning fiber, or would that like get too hot, like you say, or melt out there? I got a couple other questions, but I'm gonna do that one first.
Sure. We just announced on Monday a partnership with Google, not on data centers specifically, but basically anywhere that Google has a data center where they're contemplating a data center, if transmission is constrained, that Google will help underwrite the cost of upgrading the transmission using our product. They'll also provide training and also provide engineering support. What Randy was, Commissioner Pinocha was talking about earlier, as part of that, we announced putting basically a high temperature fiber optic core, a line in the middle of the core, basically that turns the entire line into a big sensor. We already have some fiber optics we use right now. It's used primarily for what we call our info core product. And all it does is, not all of it, but significantly what it does is it validates the integrity of the core anytime. So you can test the line before, right after it's built, or when you ship it out to the site and you put it up, you have a wind event, or you have some issue, a wildfire blows in or something, you want to make sure the core is still intact. You can test that already. This next one is taking it one step further. You'll know anywhere on the line with the temperature line at every centimeter, you'll know the strain at any centimeter, you know if a branch was to touch it or something else. People have talked about, ever since we started having the fiber optic industry, they've talked about basically being able to do fiber optics along with the transmission lines. It hasn't typically been allowed because it's two different businesses, it's a different regulatory model. But in theory, you could do it.
Well, that's interesting, because that was one of the big topics about how much need that they're going to have for glass and some of the other stuff. So, listening to what you guys are on, so I want to know what your thought is. Do you think Grid United is going to really consider the composite core for their project then, or where are we at on that?
Yeah, we're 60 to 90% review, so we're still on that front end. We haven't selected a conductor yet. Our engineer told me last week that they are looking at the carbon conductor. Whether it's any of these two, I don't know, but we're still in the early stages of that. One thing that we mentioned a minute ago, Paul mentioned at the beginning, we received a large federal grant. So anything that we do for procurement gets bid out, so people have an opportunity to participate in that, and that's just how it's going to go. So we haven't selected a whole bunch of things yet for the project. So yeah, I think we're wide open to having the conversation.
Cool. So then just one other thing, in talking with like Northwest Power and some of the other places on it. I know Missile, we're the far west end of that whole deal, but how that capacity comes through there, the big holdup, they say it's too expensive all the time. And I know I talked with some of the people at Northwestern, they said, well, the cost, and I tried to explain some of the stuff that you guys brought up here, but are they any closer, do you think, than coming along there? Because I know some of the proven stuff, what they were shoving out there wasn't quite all that there. And I know they want to, my goal is power the people, so I want to have people empowered too, and the ratepayers are always going to come first in my pocket. But so that's what I have to look out for if I was elected commissioner. But I want to know what your thought process on that talk with those people are, if you could.
With Northwestern Energy?
Well, yeah, or any MDU.
Yeah, so I don't know exactly what you're trying to get at.
Well, I'm just saying that they keep saying that the cost is too expensive for carbon fiber. So if you look at the efficiencies and what you just spelled out here, to me it's like, well, that makes sense. But I'm wondering, is it because they have like a yards and yards and miles of cable that they don't want to abandon? But when you're going to put a new project in, and I don't know, maybe the legislature could get together and say that if there's a new project that came through there, to direct the Public Service Commission to, authorize or put something in on that.
So there's basically 3 ways to increase transmission capacity. You can build a new line, like what's being done here, and this is, as I mentioned, this is very transformational, and again, applaud Grid United for using DC technology, bringing it to the Northwest. By the way, Northwest Energy is a customer of ours. They've actually put some of our product up. The second way is you can rebuild, and that's actually the preferred way. What most utilities would like to do is rebuild when they increase capacity of the existing line. And rebuild generally means you build taller towers and you put up more of the traditional stuff because it's heavier. You got to build larger and bigger towers, because that way the utility. Because I think everybody here knows a investor-owned utility. They make money based on how much capital they put in the ground that meets the criteria that the commissioner has been talking about. The cheapest way to increase transmission capacity is to just reconductor the existing lines. Basically take down the old conductor, put up either Epsilon's product or CTC's product. You get basically twice the capacity, and along with twice the capacity, you get 30% less line losses. Again, unfortunately, or fortunately, the good thing you have commissioners looking out for you, but as a general rule, no one's really all that concerned about efficiency. Grid United is, because they went with a DC line here in this opportunity, because as we mentioned, just starting off going to DC, your losses are about half of what they would have been AC, and we would argue that you could even still drop that 30% by using an advanced conductor. And then the other thing you get for free when you reconductor is you get the wildfire mitigation, wildfire resilience free with it. So it's the challenge has traditionally been the incentives are not aligned to use the new technology, because the utilities have been in business for 100 plus years now. They know the business model. They know how to make as much money as they can on that business model. And again, it's changing a little bit now because there's so much growth in transmission that even utilities can't borrow enough money to basically do all the traditional things the way they did traditionally to do the rebuilds. So we're seeing more and more of the reconductor. Our largest customer in the United States is SoCal Edison. Our second largest customers are the 2 Berkshire Hathaway utilities, Pacific Core and NV Energy, and the 3rd largest AP. And as we mentioned, we have our first projects now with Northwest Energy. So it's an education process. Since seeing the guys from Northwestern Energy came down and toured our plant, they liked what they saw and they're putting it up. But it is a challenge.
Okay, my final question then, with the AI centers coming in, we're talking about multiple gigawatts of power coming in. The cables that you have there now, have you thought about the extreme more load on it, or is they able to handle that with the efficiency on that?
I'll answer it in a way and build on what my colleague here said earlier. In theory, what should have happened with WEC is they should reconductor the existing lines. They get twice the capacity. That ship has sailed for now. In reality, in spite of all that good efforts with the line you're making, we're probably going to do that anyhow. We're going to basically have to increase. And what's one of the really good things about the DC line, and one of the real advantages of using advanced conductors, is that they tend to have a lot of headroom. We dominate, for example, Bangladesh is one of our biggest markets, and years ago, when they started buying our conductor, we really didn't know why. So we went and asked them, we're very happy that you're buying our conductor, you're putting it up in Bangladesh, but why? Why do you buy it? He said, well, we love our transmission planners, but they're always wrong. They tend to be wrong on the low side. So they basically wanted the conductor that had the most headroom, was basically the most future-proof.
All right, thank you very much.
Can I ask a question of the gentleman there? Has there been any...
Wait, sir, let me get a mic so you're on YouTube so they can hear you. So bring you the mic.
You mentioned that on the Earth you get, it's a conductor, and then you get high temperature involved with heat. Is there any way or consideration or anything new that's coming with use of ceramics, which they're using in the space rockets for the high temperature? I mean, I assume that it's, if you hold the heat in with ceramics or weight, that somehow your line won't work or something. I'm not sure about that.
Yeah, if you don't, as Commissioner mentioned, one of the advantages of the overhead transmission line is the air cools the lines. if as electricity flows down transmission, whether it's underground, you have a lot of underwater transmission, by the way, connecting actually now even North Africa to, in fact, the big DC lines connect North Africa to Spain now, but you have the water there to cool them. The problem is underground, somehow you have to dissipate the heat, or literally the aluminum will melt, and at extreme temperature, aluminum is always going to melt before the steel will, traditionally, or even the carbon fiber will. So you just literally get hot enough to melt the aluminum.
So there's no high temperature conductor line right now.
There's no,
the carbon one will melt.
Yeah, the carbon fiber, what makes the carbon fiber beneficial to the overhead application is the fact that it's light, it's strong, and it's thermally capable. You can lay a big heavy rod on the ground, it doesn't matter how strong or light it is, it's in the ground. So there's a lot of different ways to go about underground, but this fact will not change. When you go from overhead to underground, you just gain 10x in your cost, and that is the truth, no matter how you cut it, whichever way.
No matter what you do.
Yeah.
The public won't spend 10 times more because they want me to look for affordability, reliability, and they want it safe. So that's why I got to avoid underground, because it's 10 times more expensive. Oh,
so I'm just wondering, who will benefit from this project? Or maybe I should rephrase it, will there be any local benefit from this project?
Sure, yeah, happy to take that. So this project is an interregional line, so there's wide-ranging benefits. So we have 7 different utilities participating, so each of those ratepayers and each of those utilities ranging from the Pacific Northwest all the way into Minnesota, that whole North Plains region, you have different ratepayers who are going to have different benefits. And each of those utilities will go to their state PSCs or PUCs and prove up the benefit for those states. And each of those utilities has different ways that they're going to utilize the line. So they're going to in chunks. It's like Northwestern Energy is going to have 10%, and the U is going to have 150 megawatts. You've got PGE and PSC and Avista and Elite. So all of them, Berkshire Hathaway, they'll all own kind of slices of the line that they'll all benefit their ratepayers accordingly. Northwestern, who's most relevant to us, I was sitting in their office in, I guess it was January of 24, 25, I'm losing track, when it was 40 below, and they were importing 50% of the power on that day, and then we were very close to being at the upper limit. And they were they were purchasing power from CAISO at $1,000 a megawatt hour. It was at the top end. Whereas if you'd had this line built, you could have reached over and bought it at $19 from SPP. So each utility be able to demonstrate the potential benefits of the line. That's just an example for Northwestern Energy. It would be able to take advantage of the cheaper power in those moments where you go back and forth with the line and take advantage of it. I think that answers your question. Okay.
Hi, thank you all for being here. I really appreciate it. This question is for Grid United. I know that you guys did a detailed optimization study, and you completed that for the North Plains connector, but you also did something with Wyoming Intertie and the Three Corners connector, and in all those instances, you chose steel. And I also know that for this particular project, the Department of Energy has given you a grid grant for about $700 million, so that was awarded already. And part of what the grid is basically resilience and innovation partnership. They want new technologies, they want a resilient grid. So how does choosing steel for your projects actually fit in? It seems like it's contrary to what that grid grant for $700 million is for. So can you explain what you used for your criteria that you ended up choosing steel versus this other technology that's out there?
Yeah, I would go back to the fact that we haven't picked the conductor yet. I think they started with the conductor based on traditional stuff, but we're still in the 60 to 90 for this project, and those other projects are even further down the line. So I think they probably, if they spec'd it that way, I'm not sure what you're referring to exactly, but
I was looking at your optimization study, and it basically chose the ACSR.
it could be using just the traditional stuff for the study. It absolutely could be.
Well, not just for the study, but that's what you selected to, like, that you thought was superior.
Yeah, we haven't bought anything yet. We're still optimizing. So I know that for this project, they're looking at some of these advanced conductors. So I think you're looking at early stage development, kind of probably taking estimates based on traditional costs. I really like to see what you're looking at, but yeah, I know that for the North Plains connector, which is the furthest along, we haven't yet selected that conductor, but what they have been speccing out is more of the advanced conductor that we're talking about.
So generally speaking, the capital improvement for power is passed on to the ratepayer, including a 10% profit. And you said that there are 7 companies, and Northwestern and MDU are the 2 Montana. Do you have any idea as to what the final impact for that capital improvement, including the 10% profit, might be?
For their ratepayers? No,
yeah.
I don't yet. I know that Northwestern is looking at making their filing sometime here in the next 3 or 4 months, if they stay on track, and then they'll document that and make their estimates.
Gary Perry. One of the things that's been paramount and in part of your discussion and in a lot of the media is the wildfire issue. So as long as we're doing a sales pitch on carbon, how does the insurance companies look at carbon rather than steel? Or have they not evaluated it? And are they willing to have the carbon instead of the steel?
It's a great question. So we've just kind of entered the world. These conductors have been around commercially deployed for just over 20 years. So they're not new, but in transmission, they're fairly new. And especially when you look at the insurance industry, both fairly slow-moving entities. But both technologies offer reporting and inspectability. So with the composite core conductor, what you can do is you can use one of a couple of different methodologies. We each have our own. But you can get a report that says this product has not been broken during installation, after compression, after a storm. So there are health checks that you can perform on the composite that have a report associated with it with geomarked and time-stamped data. And feasibly, insurance industries could use this reporting, these reports, to confirm the structural integrity of the asset and essentially give peace of mind to those paying the insurance policies. So new, certainly something we're heading towards, and certainly could play a role here, but slow-moving industries, both transmission and insurance.
I can add to that those discussions and that type of concept is under discussion right now. They're actually, I don't know if it was just in a paper the other day or on the internet, that the first round of claims are being adjudicated in the fires in Oregon. And right now, I think they're already, it's only like been 20 or 30 plaintiffs, but they're up to $1 billion. So the insurance companies are paying attention because higher insurance rates is a direct path through to ratepayers. Higher capital costs is a higher path through directly to ratepayers, because as the perceived risk of the wildfire goes up, the cost of the capital that utilities have to borrow goes up as well, because there's perceived more risk. But I would say stay tuned. I think that's going to be an issue. I think you're going to see more negotiations around those concepts. And I apologize earlier. I started earlier. My name is Peter Brown with CTC Global. I'm the VP of VP of Policy and Grid Strategy. I didn't get a chance to introduce myself earlier, so thank you.
I would like to comment on the question about the benefit of this project, Brent. Maybe you can explain how it actually benefits Colstrip being able to send this power to the east. So,
sure. Yeah, if we're talking, far-reaching benefits for Montana, besides just a specific question about cost, you're right. So what this project does for Colstrip, you connect to the eastern markets, which you don't currently have any connection to, and as you know, some of the western markets no longer in the market for coal. So what this does is allows energy to move back and forth across that seam efficiently, let markets decide how to use things. It really puts Colstrip kind of in the center of the energy space, where you're now going to have a 3,000 megawatt tie to the east, and it's going to connect right at Colstrip. So whatever Colstrip figures for the future, I know there's lots of conversations and plans in Colstrip. It does open up lots of avenues for Colstrip to be able to develop.
And the second question I have, I can't remember if it was 47 million that was going to the Colstrip transmission line upgrade. I guess I can ask one of the other two gentlemen, have you been in contact with them? You were saying that one of the cheapest ways is upgrade, and there was a significant amount of money that was placed in that grant for that upgrade. Have you talked with Northwestern Energy about that?
Let me first talk about the grant, and then you guys can go. So the GRIP grant, I think someone mentioned it a second ago, for resiliency and improvement in technology, was a $700 million grant initially given to Montana. So Paul's office and the Department of Commerce helped apply for that grant. The last administration gave us $700 million. With the new administration, we wondered what would happen, but as time has moved on, we're moving forward with that grant with a slight haircut. They decided to take out a tribal component, and then it's kind of a Justice 40 community benefits, DEI type stuff. So they took a little bit off the top. But at the end of the day, we're looking at it, it's still a $675 million grant. Of that, about 100 of that is going to upgrading the CTS, the Colstrip transmission system from Colstrip over to essentially Townsend. So along that line, that project's been contemplated for more than a decade. So I think when they're starting to plan those things, all of it's been so far looked at is station work. So it was about $100 million. The 47 you're talking about was that TSED grant, which we're still kind of crossing our fingers, but who knows?
That's great perspective. And again, from my point of view, we have a better solution, a far superior wire. And so we're always happy to engage, come out, buy sandwiches, and talk about a better solution that will serve benefits now and benefits 100 years from now, all the same.
That's a sweet spot, I think, for both of us is reconductoring. That's basically the best economics are on reconductoring existing lines. The second best, interestingly now, are new lines, greenfield applications, so long as you can change the tower locations. Basically, because of the tariffs, because of the cost of towers, we're very competitive on greenfield transmission as well now.
Renee Pertz, and I'm familiar with your line. I have one, a sample that's sitting at my house, and I think it has a lot of benefits. The copper core, saving from the bleeding, the fire, everything you mentioned. Cost, of course, is a concern. I like the fact, I believe you were saying you can connect to the old line, if you had to do that.
You basically take down the existing line and put up the carbon fiber core, and you basically double the capacity, reduce line losses 30%, and dramatically decrease your wildfire risk. That's basically taking down, replacing. And by the way, there's some projects where that's been done live, where you can do it while the line's actually powered.
So you could do this as you're needing to replace old lines. It's like we gotta fix something here. So you could come in. It wouldn't have to be this whole thing. But I believe you're looking at more of a, let's get these babies in, which is fine, except for the cost. And we hear, I think Aussie Knudsen just won his case against, because Colstrip was forced to do this green thing, and we just won that lawsuit. And somebody can tell me, probably Lisa, how many millions or billions of dollars that we're supposed to get back from that scam, which always winds up costing the ratepayer in these things. And I think someone also just mentioned they're going to be coming, and maybe Randy would be the one to answer that, they're going to be coming to us for another rate hike, which we consistently see, and we always hear about these savings. And I love these savings. I love the fact that I didn't even realize that these lines bled a lot of power, the old lines. And incredible savings. I'm like, man, my bill's going to go down. It's going to be amazing. could we all get excited? I've yet to see this happen. Has any ratepayer seen this happen on anything? We're going to get wind in. We're going to see our rates go down. Has anybody seen that happen? I haven't seen that happen. I've seen a graph on how much power human beings are using. It hasn't gone like this. It's stayed pretty low and actually has gone down a little bit. But we're needing massive amounts of more energy. I'm just, I hate to be a negative Nelly here. And did someone just say they're going to be coming back to you, Randy, asking for more money? Or was that saying, hey, we want to give back to the ratepayer because they've been kind of overpaid? We got I believe the chair of that guy, Northwest Energy, got a $900,000 Christmas bonus. The CEO makes $6 million a year. So this is where I think citizens do have to become involved. We need to start seeing them coming to us and saying, guess what? You're going to get to benefit from this. So I'm excited about your line. I'm excited about it saving us money. I'm even more excited about the people that always seem to pay the price are sitting right here. So I'm really excited about us, even if the big boys, everybody you guys are hiring out to, would start saying maybe we don't need to personally get a paycheck for $6 million a year. I don't know anybody that's worth that personally, but then I'm not a big boy. So anyway, just my thoughts. But thank you very much.
Okay, I gotta answer a couple questions that didn't get answered very well. So this line will take energy both directions. Here's a reason why that is helpful. We put a large amount of wind turbines in, and let's say the wind is really blowing in Montana, but it's not in Minnesota. We now can take the wind from Montana and send it to Minnesota when this line is installed. Let's say the wind is in Minnesota and it's no wind in Montana, then we can bring it from Minnesota into Montana. Now, if you want to bring rates down, I need to generate more electricity than we need, and Montana needs to be an energy exporter, and then I can bring our prices down. Right now, we do not make enough electricity to supply Montana, and when I have to bring it in from out of state, I have no control over the pricing. Electricity generated in Montana, I have to approve. When I don't have enough and it comes in from out of state, that can be 10 times higher.
And you don't.
I can't regulate it when I have to beg another state for it. So I want all of you to support producing more energy than we need, and then the price will come down. And I wanted to point that.
I have 3 questions. First, has Grid United sought any abatements from the 3 counties?
Still a little soon for that. We have not yet. So taxing is an interesting question. When you look at the code sections that we think apply to a line, that's actually decided after you go to construction. So we've tried to get some certainty on the front end, and we're still kind of struggling with that.
Do you know what each county is going to get in impact fees?
I don't. No, not yet.
And then, do you know, I guess it's probably going to be a don't know, but do you know what the tax basis is going to be for each of the 3 counties? The increase in tax basis?
No, we don't know yet. We've got to figure that out with DEQ, which is an interesting process, but that is how it goes. It goes back to central assessment, and then it goes into a formula that we were still trying to find out ourselves.
Also want to point out, I'm not a big fan of wind energy because it's on and off. I like base load that's on all the time, like a dam or a coal plant or maybe a nuclear modular reactor. Wind is a pain in the butt because when I have too much, there's not much I can do with it. And when I don't have any wind and I need it, then I have to go out of state. So I'd much rather us invest in something that's base load that I can count on.
As a commissioner, we work with bidding. And you said you're going to put this out to bid, but you got 2 entirely different modes of transmission, the steel line and this So how are you gonna specify in your bid without favoring traditional compared to this new way? It's a problem. I would like to know how you do that, because, you know, that rocket that was built with the cheapest bid blew up on us. So
No, you're right. Yeah. Well, there'll be some engineering work that designs the specs first, and then we'll go out with a bid with the bid specs and be specifying what we're looking for people to compete.
one of the things it should say is we got to make sure it's less expensive for the consumer, not for the construction. That's my opinion. To get back to saving us.
Okay, to make things a little more confusing, I have two separate companies here, and I want to thank both of you for coming out. They have different technologies. I would say Joseph has an advantage over CTC Global, and CTC Global has an advantage over Epsilon. And I would like you guys to try to figure that out tonight so that you could guide Grid United. Okay? So try to learn the difference between the two companies and see if there's a savings where one carbon fiber may have an advantage over the other. So try to ask that tonight. Okay, I think the lady over here had her hand up.
This is for Grid United. I want to clarify the study that you did for the conductor optimization. You only considered steel core technology. You didn't consider anything else. And that study is what was used for the Montana DEQ Department of Environmental Quality application for the Northern Plains Connector project. And so I guess it seems like you guys are going the route of steel already by doing all your studies only with steel, doing your application with the DEQ only with steel. And so I guess I'm just trying to understand, how do you open that up and why did you only do it with steel?
Yeah, again, this is outside of my expertise. I'm just the lawyer in history. I'm not an engineer. However, when we have looked at this in the past, when they did those initial studies, that was initial work based on historical, conductor.
That was August, though. The DEQ application was August.
For sure. I'm not saying that the DEQ. Yeah, no, I'm saying the studies were based on traditional technology. So when I've talked with our engineers most recently, they've been looking at these other conductor options. And if we go back and do a different conductor, then it would just be, we'll look at the DEQ and what we've told people, and we'll update things. But yeah, I take your point. Yeah, what we've provided so far has been studying based on the steel conductor, but now we're getting into the final stages of the engineering from the 60 to 90%, and we're looking at the rest of it. So, but I'm happy to follow up with you and continue to have this dialogue, so you just feel like we're giving you the full scoop.
Linda.
You guys are having, right?
I was asked if you had mentioned fiberglass on the lines. Is that someplace that can shed, considering we've had some interesting conversations on some of these meetings with the fiberglass shedding?
No. So these composite cores, they're made with boron-free e-glass. So we learned in the 70s with fiberglass insulators that you do not want boron content in your fiberglass in this application. It's a engineered solution that's been tested and commercially deployed all over the world in the most tough conditions. The resin and the glass and the carbon are engineered to work together to benefit the line, the sag clearance, whatever the point of it. But to answer your question, no, the fiberglass is not at risk of shedding. And again, if during installation or shipping there is damage to the conductor, we both have methodologies that we can check the conductor and say, it's 100% good, here's a report, or there's been a defect in the glass layer, we need to strip back the aluminum and take a look. That's a diagnostic that is only available with composite core, will never be available with steel.
Okay, a couple things there, Joseph. And it's a good question. Fiberglass, like you see on a boat, is completely different than carbon fiber. Is that correct? And carbon fiber is 10 times stronger than fiberglass, right?
Fiberglass is different than carbon fiber, and carbon fiber is stronger than fiberglass. That's
Okay,
correct.
so let's start there. Okay, now next, when you said you could check the condition of the line, that means you can check it while it's up and it's in operation. You can check that line electronically with a computer or a steel core. We cannot. Is that correct?
Yeah, I don't want to blend the two worlds. There's one technology called real-time monitoring, and there's a few ways to do that. One is a very capable gated optic fiber included into the OD of the conductor. That's one methodology. There's other equipment that attach onto the conductor or take control of an overhead or above wire, a guide wire, and that can tell you about the condition. So real-time monitoring in our industry is one thing. What I'm focused on is replacing heavy corrosive steel with carbon fiber. And now when you go to carbon fiber, what you can do is you can interrogate the core to make sure that it still has structural integrity. So if you get a storm and you want to go back out and make sure that the line is still good, you can go with your test and test it and say, make sure that it's good. When we talk about understanding tension, temperature, all of those things, that's real-time monitoring, and we have a couple different ways to go about that. I know CTC has a couple different ways too. But those are, I want to separate those two categories. There's real-time monitoring, and then there's replacing a 1907 technology with a carbon fiber composite.
Thank you, Jerry Schoner. Earlier there was a question about how this is a transmission line and how does it benefit people along the way. And I think there's not on and off ramps along the way. This is along transmission lines. So maybe you'd just like to explain, as you mentioned earlier, different utilities have different slices of this or capacity. Maybe you can explain some of the difference between transmission and distribution and just how these people in between will benefit.
Do that. Okay. Yeah, so this is a DC line. So the DC line goes from Colstrip and ends just southwest of Bismarck. That blue line, if you remember, still up. The blue line is a DC line. That is not going to be interrupted. Each time you were trying to tap into that line, with a small price tag of about $750 million and 6 years of development. So there will not be additional taps in the middle of that line. So a lot of the landowners have appreciated that. That doesn't mean people are going to be building a lot of lines connecting into their communities. Different from distribution entirely. The distribution networks will be on either end. The lines that already exist, it will just be energizing the existing system.
Paul Green. Sorry, once again, there was a question over here about impact fees into the communities. The haircut that Brent was talking about, unfortunately, we did write into the grant some impact fees to help the communities the 3 counties were supposed to receive, but unfortunately that was something that got cut out from the grant.
And I would just add, Paul, so there's the community investment program that you may have heard about. We've been doing that for the last 3 years. We pushed that forward another 3 years outside of the grant. We funded that anyway, even though they took it out of the grant. Then there was this other TSED grant, which was going to be another $47 million, which would be great. We just haven't heard anything about the federal government. That wasn't our grant. That was applied for by the communities, which you may have heard about.
Do I have any questions? Any hands up? All right, so I've got to get right to this question. There's some advantages that each one of these companies have. Epsilon has an advantage, and CTC Global, I think, has certain advantages. And my first question is for CTC Global. They have the newest technology out called Vista. Peter, I'd like you to explain the latest technology you have out today and what the benefits are. And I believe you're the only company that offers these benefits. And I'd like you to explain to everybody here what that is.
So the product is actually called Grid Vista. And basically, as I described it earlier, it's basically the same product you see here, except in the center there's a fiber optic cable that acts as a sensor. So you basically have active, online, 24/7 intelligence on what's happening with the line. Allows you to optimize the power being transferred through it, visibility on issues along the line, That was just announced on Monday in a partnership with Google. We think it's going to be transformational because among other things, for people like Grid Vista or the utilities, it's going to, you have a pretty good idea where the line caused a fire, but you can also, more importantly now, show that maybe the line didn't cause a fire, among other things, but also the optimizing capacity for the environmental conditions.
Okay, Joseph, tell me a little bit about some of the things you can do and your advantages.
Well, when I look at this application, Epsilon being a tier 1 supplier to Airbus, we do a lot of work in resin chemistries. And so what we've done is we've kind of made a composite core specifically for New Line Greenfield. And so it's not as thermally capable. This is not a double ampacity reconductory in an existing corridor argument. This is save on CapEx with a cost-effective composite. The price of carbon fiber is coming down, the price of fiberglass is coming down, and the price of steel is getting taxed and going up. And so the costs associated with these products and at their given performance, as I showed earlier, it's becoming more and more able to be realized on a New Line Greenfield application. So we would actually recommend that more cost-effective composite that's less thermally rated in this case, because you don't require the same thermal considerations on this DC application. So because it's a cheaper wire now, you have a cheaper upfront cost. You'd be able to save money up front with the tower reduction, and then you get the 100-year savings in perpetuity. So benefits here and benefits there, and really being able to optimize the composite from a fiber architecture perspective, a resin perspective, tailor fit the composite to the application, and make sure that it works through every aspect or consideration that Grid United would have.
Greg's telling me we got to wrap up. And I got like 26 more questions. Come on, you guys, let's get into this. All right, so it looks like I'm having dinner with Mike Scully, the CEO of Grid United, in Washington, Seattle, a couple of months ago, and I really appreciate you guys coming out. And Mr. Scully tells me, look, Pinocchi, I don't think carbon fiber can meet our specifications for this particular line. It's so big. And I said, no, wait a minute. I believe I got two companies that'll custom build to meet your specifications, okay? So, as I understand it, Epsilon has an answer that could be the same price as steel or close to it. Is that correct?
That's correct, yeah.
And we have the advantages of saving line loss and having the towers farther apart. So there's no question it would be cheaper for them to do this, safer for fire, and I cut line loss to save my ratepayers $100 million over the life, maybe $200 million. Is that correct?
Yeah, so the engineers can twist the knobs on each of these categories to find the right solution, and we've seen it come to fruition globally in Africa, the Middle East. It has happened. It's been engineered. It's been built. It's come to fruition. So not only is it possible, there's evidence on a global scale that it has happened.
See the importance. I'm saving you hundreds of millions of dollars here, okay? All right, now, CTC Global, you have this advantage where you can do this additional monitoring, but you may still be the cheaper choice because we're going to subtract some towers, stretch the line farther. Do you feel confident that you will have a price that may be more competitive over steel?
Assuming the towers are not fixed, in other words, you can reduce the amount of towers, we believe would be very competitive, probably lower cost. Plus, you'll have an additional 100 years, 50 years, 100 years of savings because of efficiency.
Tell us the advantage on your technology that's patented that you'll be able to do that no one else can.
Well, basically, you'll know the load and the temperature at a given time. So basically, you'll be in positions where it is really cold outside, and in wintertime, which also has to be a time where the lines are very, very heavily loaded. You can put a lot more current down the line if needed. So basically, you can optimize the amount of power that comes down the line. Also, you start with 30% more aluminum in the air, so you get that efficiency advantage and that capacity advantage as well.
In Louisiana, they had a power outage. No problem. We're going to route the power through this other transmission line and get the lights turned back on. So they had to increase the load on the transmission line. So when they dialed it up, the line basically turned red hot, melted, hit the ground, and started fires.
We will be able to avoid that problem because you can monitor the temperature and you'll know where the limit is when we have an emergency. Is that correct?
That's correct.
You see, that is why carbon fiber with the technology in the core is so important. So I'm asking you to help me get the Powerline that has anti-lock brakes and airbags over 1907 technology where we didn't even have blinkers on the car or even a seatbelt. That's what I'm trying to get you guys to catch, and I need your help to make that happen. With that, I'm out of time. Is that correct?
That is correct.
All right. I will stay here until the last person leaves to answer any question, especially the buried transmission. And I'll tell you my radiator closed loop system example of underground transmission. Thank you.
Thank you.